Good afternoon, everybody. Hope you're all healthy and safe at home. So we are going to begin with our fourth semester. Last semester was a bit in the end it was a bit in a hurry, but still we'll try to make up with that by doing the revision, and also don't worry about those things. So today we shall begin with the fourth semester, and fourth semester first module 1. So in this module we are basically dealing with the differential equations. Okay, so differential equations, we all know what an equation is. Like x plus y is equal to 10, that is an equation. Okay, equating two sides, that is called an equation. So what will be differential equation? An equation which contains terms of derivatives. Okay, we are familiar with the derivative things, and we have learned higher derivatives, we have learned partial derivatives. All these we have learned in the previous classes or previous semester and all. So the equations which contain differential variables like derivatives will be called as the differential equation. So let's see the proper definition of it. So in this section 1.1, we are basically dealing with the definitions and the terminologies related to the differential equation and all. So first of all, the definition of differential equation: an equation containing the derivatives of one or more dependent variables with respect to one or more independent variables is said to be a differential equation. Okay, so a differential equation, it consists derivatives. Okay, derivatives, it can be just simple derivatives, dy by dx, or d square y by dx square. It can be d square also. Higher order derivatives is also possible, and partial derivatives are also possible. So an equation which contains derivatives, and the derivatives, the conditions are that it can be containing of one or more dependent variable or one or more independent variable. Now what is this dependent and independent variable? I think you guys must be familiar with it. Like if you are finding the derivative of y with respect to x, then in those case, or dy by dx means y is the dependent variable, y is depending on x, because if we have to derivate y with respect to x means y must be a function of x something, right? So y is depending on x and x is the independent variable. So that is the condition of dependent and independent variable. Now if you are considering like x as a function of u and v also, okay, that is when the partial derivative comes into existence. It is dou x by dou u, dou x by dou v and all. So in that case, x is the independent variable, it is depending on u and v, and u and v are there the corresponding independent variables. Okay, so that is dependent variable and independent variable, and what is meant by a differential equation. Now based on various type or order or linearity and all, we are going to classify this differential equation. Okay, there are many classifications of this differential equation. So first of all, we will discuss the classification by type. Okay, by the type of the differential equation. So there are basically two types of differential equation. Okay, ordinary differential equation and partial differential equation. So in ordinary differential equation, the differential equation contains only ordinary derivatives. Okay, this is the important point, that is, it contains only ordinary derivatives like dy by dx, dy by d square y by dx square and all, that is of one or more functions with respect to a single independent variable. Okay, so when we are talking about single independent variable, there will be only normal differential equations, right? Like differential derivatives will be existing, like dy by dx or d cube y by dx cube. Okay, higher order ones. There won't be the case of dou won't come into picture, because we are just considering the functions which are depending on just a single independent variable. Okay, so that is called the ordinary differential equation. And the next is the partial differential equation, or PDE. Ordinary differential equation short form is ODE, and partial differential equation short form is PDE. Okay, an equation involving only partial derivatives. Okay, partial differential equation involves only partial derivatives of one or more functions of two or more independent variables. So in case of partial differential equation, there can be more than one independent variable, then only partial derivatives will occur, right? So these are the two types of differential equation based on the type, that is on ordinary derivatives and partial derivatives. So let's just see few examples to recognize ordinary and partial derivatives. So here if you see example 1, the equation is dy by dx plus 6y is equal to e raised to minus x. So here in this equation there is only dy by dx, that is, it is an ordinary derivative. So this is ordinary differential equation. Okay, now here also d square y by dx square plus dy by dx minus 12y is equal to 0. Here also there are only ordinary derivatives, so there is no problem. Now in the last one, dx by dt plus dy by dt is equal to 3x plus 2y. Okay, here also we are having ordinary derivatives, and there is still, again you can see that there is only one dependent variable, one independent variable t. So ordinary differential equation means there must be only one independent variable. Here there is only one independent variable, but there are two dependent variables. That is possible. There is no restriction in the number of dependent variables, but the number of independent variable in case of ordinary differential equation must be just a single one. There must be only one independent variable. So dx by dt plus dy by dt is equal to 3x plus 2y is also a ordinary differential equation. So ordinary differential equations basically contains only d by dx, d by dt, all those such forms. Now what will be the case of partial differential equation? Partial differential equations will have partial derivatives in them. Like for example, dou square u by dou x square plus dou square u by dou y square is equal to 0. So here u is a single independent dependent variable, x and y are two independent variables. Okay. Dou square u by dou x square is equal to dou square u by dou t square minus dou u by dou t is another example of a partial differential equation. Dou u by dou y is equal to minus dou v by dou x. So here we have two dependent variables and two independent variables. So in case of differential equations, the number of dependent variables can be more than one or more than one, but in ODE the number of independent variable will be just one, and in PDE the number of independent variable can be one or more than one. Not one, it cannot be one, it can be more than one, it should be more than one. So this is these are the two examples of the ODE and PDE. Now in this textbook, this is about a note about notation that you are seeing, that is usually we write dy by dx or d square y by dx square or d cube y by dx cube. This is called as the Leibniz notation. Or we have the prime notation, that is y prime, y double prime, y triple prime, and so on. But after y triple prime we write y raised to 4. Okay, that is the nth derivative. You can see the nth derivative is given by d raised to n y by dx raised to n or y of n. Okay, and sometimes we also have this subscript notation also, like uxx. This is how we had denoted the partial derivatives. Okay, this is the case of ordinary derivatives, and this is the case of partial derivatives, like uxx plus uyy is equal to 0, or uxx is equal to utt minus ut. That is, this uxx is nothing but dou square u by dou x square. Okay, and this is equal to dou square u by dou t square minus dou u by dou t. Okay, so that is the notations that we'll be following. So usually we consider the prime notation, y dash, y double dash, that is simpler to write, and sometimes nth derivative is written like d raised to n into y divided by dx raised to n. So all the types of notations we use, and mostly in partial we use the subscript notation only. So that is how we can classify the differential equation on the basis of type. Now next is the classification by order. Okay, now you guys must be familiar with the polynomial equation, and we know what is the order of a order and degree of a particular polynomial, right? So same case or same thing is applicable in case of differential equation. So here the order of the differential equation is the order of the highest derivative in the equation. Okay, so if you are given a polynomial x cube plus 3x square plus 1 equal to 0, what will be the order of that equation? It will be 3, right? That is the highest degree, highest order, highest power of x. So here also the same concept, but it will be the highest power of the derivative which is given to us. Okay, so if we have dy by dx, then what is the highest power occurring in that particular equation? That will be the order of the differential equation. Now we can make a note, that is general first order differential equation can be sometimes written in the form, the general form is m of xy dx plus n of xy dy. Okay, like if we rearrange this, that is if I take this n of xy dy in this side, and if I take n to the denominator, so I'll get dy by dx is equal to m by n, right? So again, that is a first order differential equation, right? Dy by dx, the highest power is 1 of the differential. Okay, so this is about the order of the differential equation. So we can see the example or some examples which depicts the same concept. That is example 2. The differential equations are given to us. They are like d square y by dx square plus 5 into dy by dx cube minus 4y equal to e raised to x. So what will be the order? Never get confused with it. What is the order? It is the power of the derivative, highest derivative. Okay, highest derivative. Okay, so don't get confused with 2 and 3. 3 is not the order. Here we have y d square y, that is second derivative is present, and first derivative has to be taken to the power 3. Okay, so second derivative is there, so the order of this differential equation is 2. And what will be the order of this PDE? It will be 4. Okay, so I hope the order is clear. That is the power or the order of the highest derivative will give us the order of the differential equation. Now another form is like this is the, I had mentioned that the first order differential equation can be written in this form. So if you are given any differential equation, then we can convert it into this form. Like if you see the first one, the differential equation is y minus x dx plus 4x dy equal to 0. So this is the general differential equation of the first form. It is of this form, right? M into dx plus n into dy. So here m is y minus x and n is 4x. So I can write this as this is the first order differential equation. That is the explanation. You can rearrange it. That is, if I take dx, if I divide the whole equation by dx, what do I get? Y minus x plus 4x into dy by dx is equal to 0. Or I can write this as 4x into dy by dx plus y is equal to x. So in this case, this is a differential equation because it has a derivative in it and the highest order is 1. So this is the first order differential equation. Okay. Now if you are given a differential equation of this form, like 6xy into dy by dx plus x square plus y square is equal to 0. So I am going to divide this by or the whole equation. If I am going to multiply this equation by dx, what do I get? This dx will get cancelled, so I'll get 6xy dy plus x square plus y square into dx equal to 0. So that is the form mxy dx plus nxy dy. So this example actually tells us that a differential equation which is of this form, m dx plus n dy, is basically a first order differential equation. Okay, we can rearrange it to form a first order differential equation. And sometimes we write a differential equation in this form also, like this is called as a general form. Okay, like f of x, y, y dash, etc. y raised to n. That is a differential equation contains n order derivatives and the dependent variable. There is only one independent variable, right, in case of ODE. So we can write this is y is depending on x. Okay, y dash and all will be the independent dependent one, and the independent variable will be x. So we know that an ordinary differential equation contains just a single independent variable. So here we can write an ordinary differential equation in this form: f of x, y, y dash, etc., y raised to n equal to 0. And related to that, we can write it and we can convert it into normal form. That is like what should I say, I'm keeping the derivative, highest derivative on one side and taking the other terms on the other side. Okay, so in this case, sometimes the differential equation d raised to n y by dx raised to n is equal to f of a function of x, y, y dash, etc., y raised to n minus 1. Okay, f is a continuous, real valued continuous function. This is called as a normal form. So we have learned two types of form. One is a general form, that is writing everything together, okay, and in a simplified form on one side. Okay, there is just these are both the case of ordinary differential equation. We can write only ordinary differential equation either in the general form or the normal form. In general form, all the derivatives and the corresponding coefficients, everything will be on one side. It is equated to 0. And in our normal form, we will take the highest derivative and make the coefficient of the highest order derivative to be 1, and we'll write all other terms on the other side. Okay, like dy by dx is equal to f of x y, d square y by dx square is equal to f of x y y dash. Now, example 4 also depicts an example of normal form. That is, if we consider the equation 4x into dy by dx plus y equal to x, to convert this into normal form, our aim is to keep only this term on one side and the rest all the other side. So it will be x minus y divided by 4x. dy by dx is equal to x minus y by 4x. And suppose we are given y double dash minus y dash plus 6y is equal to 0. So here highest derivative is y double dash. So y double dash must be kept on one side and all other terms on the other side. Okay, so that is the two types of ordinary differential equation and how we classified, how to write them. Okay, so in this type of classification by order, we had considered what is the order of the differential equation, and we have considered two types of two forms in which an ordinary differential equation can be written. One is the general form. In the general form, everything will be on one side, and on the other side, on the right hand side, we will have only 0. And in the normal form, the highest derivative will be kept on one side and all other terms on the other side. So that was our classification by order. So next is the classification by linearity. Okay, whether a given differential equation is linear or not. Now, by the linear differential equation, what we mean is the variable y is linear in, we can say, an nth order differential equation is said to be linear in the variable y if the equation is linear in y, y dash, y double dash, etc., y raised to n. Okay, I hope you guys get the picture. That is, given in a differential equation, if there are what should I say, there should be no powers of y dash, y double dash, etc., and there should be no product also. Okay, product of y, y dash, or something like that. Okay, then that is, the variable y must be linear. Linear means what? It should have no any higher powers must not be present. Okay, so you can see the general form is given to us: an of x into d raised to n y by dx raised to n plus an minus 1 of x d raised to n minus 1 y by dx raised to n minus 1, etc. a naught x into y is equal to gx. So here you can see that y, dy by dx, and all other derivatives has power 1. It has no higher power. Okay, that should not be present. And also the coefficients are all depending on the only independent variable. Okay, they are not depending on y. That is, y into y dash plus 2y is equal to 0. That is not a linear differential equation because there is y into y dash. Product of the dependent variable with its derivative must also not be present. So the next 2 points is actually which will be we'll be using often. That is the linear first order equation and the linear second order equation. So the linear first order equation is of the form a1 of x into dy by dx plus a dot of xy equal to gx. Okay, here dy by dx and y both have power 1, and a1 and a dot are the coefficients and they are all depending on only x. Now linear second order equation will be of the form a2 of x into d square y by dx square plus a1 of x into dy by dx plus a dot of x into y equal to g of x. That is another example of, that is the general form of a second order differential equation. So the linear differential equation. So for a differential equation to be linear, the powers of y, y dash, y double dash, etc. must be 1, and there should be no product also present in that particular differential equation. So these are the two nodes which I have just now stated, that is the dependent variable y and all its derivative y dash, y double dash, etc. y raised to n are of first degree. Okay, that is the power of each term involving y is 1. There will be no higher powers. Also the second one, the coefficients a dot, a1, etc. an of y, y dash, y double dash, etc. y raised to n depend at most on the independent variable x. So it should not depend on any other variable. Okay, that is the coefficient must not be dependent on any other variable. So these are the two notes that we must keep in mind while considering the classification by linearity. So never get confused with what is a linear differential equation. Now once we have the term linear, there will be what is meant by non-linear also. So any differential equation which is non-linear, which is not linear, is called a non-linear differential equation. So that means in a non-linear differential equation there can be powers of y, y double dash, etc. and like the coefficients of y, y dash, y double dash can contain the dependent variable y, like the example that I stated, that is y into y double dash plus 2y is equal to 0. That is a non-linear differential equation because there is a product, the coefficient is depending on, or it is contains the dependent variable y. So any just learn one definition and the other one is opposite of it. So if you know what is linear differential equation, non-linear is a differential equation which is not linear. Okay, so that is an example of the the definition of the non-linear equation. Now we shall see an example so that the concept is a little bit more clear. So if you see, here we have y minus x dx plus 4x into dy is equal to 0. Rearranging this, we can find that there is only dy by dx in this equation. So this is a linear differential equation and its order will be 1. Now here we have y double dash minus 2y dash plus y is equal to 0. This is also linear. Then we have x cube into d cube y by dx cube plus 3x dy by dx minus 5y equal to 0. So here and all the powers of the derivatives are all 1. Also the coefficients are depending on only x, right, or it is a constant. So there is no y in it. So this is a first order differential equation, this is second order, this is third order. Now here these are B gives us the example of non-linear equations. That is, if you see 1 minus y into y dash plus 2y is equal to e raised to x. So here there is a product y into y dash will be existing. So that will be non-linear. Then in case of non-linear equation like sin x, e raised to x, trigonometric exponential functions and all, if they are present, they are also not linear differential equation. Okay. So that's keeping in mind. That is, so if you have d square y by dx square plus sin y is equal to 0. So here the derivative, highest derivative has power 1. Okay, but that does not mean that this is linear because we have the expression sin y. So if we have any trigonometric functions or exponential functions present in the particular equation, that is not linear. Now here again we have d raised to 4y by dx raised to 4 plus y square is equal to 0. So once y square, y dash cube, all these are present, then we can straight away say that it is non-linear. So these are the examples of non-linear differential equation. So that is the classification by linearity. So in this lecture we had basically done it with just the classification of what is a differential equation and the classification in terms of type, that is ordinary differential equation and partial differential equation, and classification by order. In that we had the general form and the normal form, and last by linearity we had the linear differential equation and the non-linear differential equation. So these are the basic definitions and terminologies which you have to keep in mind. Then only we can move further with the sections to solve the differential equation and all. So that's it for today's session. Thank you. Stay home and stay safe.